In this video, we're going to be looking at examples of solving two-step inequalities. So our first example is 7x plus 10 is greater than or equal to 66. Okay, so this process is just like solving two-step equations. We just have to be careful that we're using the right inequality sign. So I have 7 times x plus 10 is greater than or equal to 66. So let's think about what's happening to x. Kind of thinking about our flowchart method just off to the side. I'm taking x, and then it's getting multiplied by 7. Then we add 10, and that gives us 66. Okay, so then I need to work backwards. So my first step is going to be undoing this adding 10. So how do you undo adding 10? You subtract 10. Okay, so minus 10. That's my first step. So that's what I'm going to do here. I'll rewrite my equation, my inequality. 7x plus 10 is greater than or equal to 66. And then on both sides of the inequality, I'm going to undo that adding 10 by subtracting 10. Alright, so I have plus 10 minus 10. Right, I've added 10, I subtracted 10. Those undo each other, they go away. Right, 10 plus 10 is 0. So I'm just going to cross it all out right now. We could write plus 0, that would work too. I'm going to cross it out, that goes away. Okay, and all I get on this side then is 7x. And that's going to be greater than or equal to 66 minus 10. 66 minus 10 is 56. Alright, and now I have a one-step inequality, which we've been solving. I can go back to my flowchart. Now I have this x is getting multiplied by 7. So how do you undo multiplying by 7? You divide by 7. Right, and that's going to give me whatever x is. So I have x times 7, and I'm going to divide by 7, divide by 7. Okay, when I do that, 7x divided by 7, the 7's cancel. 7 times 7 divided by 7 is just like multiplying by 1. They undo each other, it goes away. Okay, so I just get x on this side, which is the goal. I still have my greater than or equal to sign, and then I just have whatever 56 divided by 7 is. And 7 times 8 is 56, so 56 divided by 7 is 8. So then my solutions is x is greater than or equal to 8. Any number that's greater than or equal to 8 is going to make this inequality true. So lastly, we want to go ahead and just graph that solution. Guys, so I'm going to draw a number line for myself. Doesn't have to be beautiful. I have 8 at the center. 9 is going to be to the right of it. 7 is going to be the left. And I want to graph all my solutions that are greater than or equal to 8. So when I have or equal to, that means I have a closed point, because I'm including 8 as one of my solutions. And then greater than means I'm going to the direction where numbers get bigger, which is to the right. Okay, so then I'm saying going greater than 8. And that's my final solution. So I do this little flow chart up there, even if you can't see it very well. You can keep doing that. I know some of us became comfortable with that. But I do want to get us towards this method, right? Where you see we're doing the exact same thing we were doing in the flowchart. We're just writing it out differently. All right, let's look at another example. So here we have negative 2 times x plus 5 is less than negative 9. So I want to go ahead and solve this. And I'm not really going to use the flowchart method, but I can look at it to help me understand what's going on. So first I have x is getting multiplied by negative 2. And then we add 5. And when you take x, you multiply negative 2 and add 5, we need to get a value that's less than negative 9. So when we go ahead and solve this inequality, we're going to undo what's currently happening to the variable, just like we've been doing with solving equations, in order to find our solutions. So we have plus 5 here. Okay, we need to first undo that adding 5 by subtracting 5. Okay, so that's what I'm going to do first. I'm going to rewrite the inequality I currently have. Negative 2x plus 5 is less than negative 9. And then on both sides, I'm just going to undo that adding 5 by subtracting 5. Okay? Just like before, when I have plus 5 minus 5, that equals 0. Adding 0 doesn't do anything. It's just going to go away. So I'm just going to cross that off. And then on the left-hand side, I get negative 2 times x. And that's going to be less than whatever negative 9 minus 5 is. Okay, negative 9 minus 5 is negative 14. Remember, that's the same thing as negative 9 plus a negative 5. Alright, so I've undone that adding 5 by subtracting 5. Now I have to undo what's currently happening to the x here. X is getting multiplied by negative 2. So I undo multiplying by negative 2 by dividing by negative 2. Right, so that would be the second step. This is just keeping track of what I'm doing. Okay, so if I undo multiplying by negative 2 by dividing by negative 2, of course I need to do that to both sides of my inequality. Okay, so when I divide or multiply by a negative number, when I have inequalities, I have to flip the sign. Remember that. We remember that from solving one-step inequalities. So that means I'm going to flip from less than to greater than. And then we'll just take care of the two sides individually. I have negative 2 times x divided by negative 2. The negative 2's cancel away. They divide, they get 1, and I'm just left with x on this side. And then on the right-hand side, I have negative 14 divided by negative 2. A negative divided by negative is a positive. So this is going to give me positive 7. So that's going to be the solution. X is greater than 7. Again, let's talk through what I did. So I needed to undo everything that was happening to the x. First, x was getting added by 5. So I undid that by subtracting 5. And if I do it to this side, I need to do it to this side always. For any inequality, any equation. So 5 minus 5, that goes away. I just get my negative 2x, just like I was hoping. Negative 2 times x is less than negative 14. I need to undo multiplying by negative 2, so I divide by negative 2. And of course, I have to do that to both sides. Let's just add a little note for ourselves here. Remember, when you multiply or divide by a negative, you flip the inequality sign. Okay? So, as long as we remember that, that's all right. When you flip or when you multiply or divide by a negative number, you're going to flip the inequality sign. Okay, so now I have my solution. This says that for any number that's greater than 7, that's going to make this inequality true. So if I substitute a value, for example, I substitute a value like 10. 10 is greater than 7. I'll have negative 2 times 10, that's negative 20, plus 5 is negative 15. That needs to be less than negative 9, and that is true. Negative 15 is less than negative 9 because it's farther left, farther away from 0. Alright, so let's graph our solutions then. There's my kind of messy number line. Get the idea. Okay, I have 7 in the middle. My solution is all values that are greater than 7. Since it's just greater, not greater or equal to, I'm going to have an open circle at 7 because it doesn't include 7. And then I need to make an arrow pointing to the right because I'm talking about values that are greater than 7. Values that are greater than 7, like 8, are to the right of 7. Okay? So this graph represents all my solutions to my inequality, all values that are greater than 7.